Welcome to Train Signal. This is the Managing Drivers and Hardware Devices lesson in the Windows 7 Administration Training course. In this lesson, you'll learn how to manage drivers and hardware devices, starting with the use of the Device Manager tool that's been built into every version of Windows for the past very long time. You'll then learn how to use the System Information tool to gain an in-depth read-only view that even Device Manager doesn't provide you in a concise format. You'll learn about drivers and driver installation methods, and learn how to manage drivers that are installed on your system. You'll then get a brief look at the developer-focused driver verifier utility, and you'll learn how to manage hardware installation policies. I'll then show you how to stage drivers with the plug-and-play utility called pnputil.exe, and show you how to add device drivers to the driver store. We'll wrap up the lesson by learning how to monitor USB driver bandwidth and power consumption. Global Mantix has an array of computing needs. There are no single desktop hardware configurations out there, so creating a single desktop image is a challenge, and making sure that you're managing desktops in a central way and in a consistent way can also be difficult because of the different hardware components that exist on different models of computers. As one example, the marketing department, because of some of their storage requirements that are connected to the network, requires specialized network adapters, while other users have a more mainstream configuration. In order to keep device installation a seamless process and to keep the total cost of ownership of the desktop environment low, you've been asked to learn how to pre-stage device drivers to make sure that as people add specialized network adapters, that there's no driver issues that pop up. This will help users get their work done by making sure that their necessary hardware devices work and are well maintained. It's a good deal all around, and it's important for Global Mantix in order to keep that cost of ownership at a low level. If you've used Windows at all, you've probably been exposed to the Device Manager. This is really the default tool by which hardware devices are managed in Windows and in Windows 7 as well. From here, you can view device and driver information, including device resources, and you can even view hidden devices. You can also make configuration changes to hardware devices, and you can do driver updates right from the Device Manager. Let's go over to a Windows 7 machine now that's a Global Mantix machine, and take a look at Device Manager and some of its capabilities. We're on a Windows 7 desktop for Global Mantix now, and to get the Device Manager, we'll go to the Start menu, right-click Computer and choose Properties, and then click Device Manager. This brings up the Device Manager tool that's been present in Windows for a very long time. What you're seeing right now are a list of categories that are available for each device type in Windows 7. And as you can see, as I click the little arrows next to each device type, a list of all of the devices inside that particular category shows its face. And you can start taking a look at what exactly is included in each of these items. Let's go up and take a look at the video device. I've right-clicked that device, and from here I have a number of options. One, I can update the driver software. I can actually go out and search for the driver software, or I can install a previously downloaded copy of the driver software. I can disable this device, which I really don't want to do because I like having video. Or I can uninstall this device. Again, the aforementioned need for video will prevent me from doing this, so I won't do it. If I've added a device, but for some reason it hasn't been picked up by the system, I can also initiate a hardware scan that will go out and scan all of the various buses on the system for what may be new devices, and then those will be added to the system if they're plug-and-play compliant. Finally, I can choose properties for this device. And from here, I can also provide some additional capabilities, including updating the driver, disabling the device, uninstalling the device, or I can get information about the driver. Here, you're seeing that there are a couple of drivers that are being used by this device, including the VMBus Video M.sys driver, as well as the VMBus Video D.dll. From here, I can get detailed information about the device, including its hardware ID, compatible IDs, class of device, configuration flags, and as you can see, a whole lot more information. In your normal day-to-day, you won't really be using this Details tab very often. However, if you begin having problems with a device, or you need to go into a little bit more specialized configuration, you may need to use this Details tab to find some of this information. For example, if you wanted to prevent this device from installing, you would need to understand its device ID or its hardware ID. And this is available on the Hardware IDs page of the Details tab. You would then use this and the local group policy editor to prevent this device from being used on the system. And we'll be doing that later in this video. On the Resources tab, you get some other information, including the memory range that's used by this particular device. If you've used computers for a long time, you may remember a day when there were a whole bunch of other pieces of information that were necessary for our devices to work. Let's take a look at the keyboard port, for example. If we go to the Resources tab on that, you'll notice that it has an IRQ value, and it has a number 1. IRQ stands for Interrupt Request, and these are the I/O ranges that this device uses for its standard operations. In the olden days, there were a very few number of interrupt requests values that were available, and most of them were taken up by typical hardware devices, such as printer ports, serial ports, and keyboards and mice. You had to be very, very careful about sharing these IRQ values, and in some cases you couldn't even share them, so it was very difficult sometimes to add devices. Today, with all kinds of enhancements to hardware devices, IRQ is almost never an issue. But you should understand, if you're working with older devices, that IRQ could raise its ugly head, and you may need to troubleshoot IRQs to make sure that you're not conflicting, or if you're using a very old system that's not running Windows 7. But that's not the focus here. So understand IRQ values just very loosely, and understand that you're probably not going to have to do much with those either. Frankly, hardware devices in Windows 7 really just work. It's pretty amazing how far Microsoft has come with respect to making sure that hardware devices work the way that they're supposed to. Now, there may be some devices that are not seen here as well. If you go up to the View menu, you can choose to show hidden devices as well. And then if there's some devices that for some reason are not being shown in the default view, for example, non-plug-and-play drivers, you can see those devices as well and manage them just like you would any other device. The Device Manager is just one tool that you can use to get information about your system. The aptly named System Information Utility is another tool that you can use to gain information about your system. It provides a much greater level of detail about the system devices and resources in a way that's really easier to read. However, it's a read-only tool. Unlike Device Manager, in which you can actually make changes to a device configuration, the System Information Utility is a one-way affair. You can look, but you can't touch. We're going to go back over to our Windows 7 system now and take a look at the System Information Utility and what it can provide. To get to the System Information Utility, you can go to the Start menu and use the handy-dandy search tool and just type System. And then you'll see under Program, System Information. You'll start out with a system summary, which provides you with a plethora of information about this particular system, including the fact that it's a 64-bit machine, that's a virtual machine from Microsoft, so it's based on Hyper-V, and it's running Windows 7 Enterprise. And the processor is a Xeon 5355. It's got a gig of RAM, Central Daylight Time, basically anything you want to know about the machine itself. Where you get some interesting information is when you start looking at the hardware resources, starting with the Conflicts and Sharing tab. Now, be careful about the word conflicts because it's generally not a big deal in Windows 7 land anymore. All that you're seeing here is a list of devices that happen to be sharing some kind of resources. These ones are sharing an I/O port, and this set of devices happens to be sharing some memory addresses. Back in the olden days, this would have been a problem. These days, not really a big deal anymore. So it's only if you're having trouble with a hardware device should you come over here and get concerned if you see that there are conflicts. You can also get some information about direct memory access tools, including what channel things are using. There's nothing on forced hardware. But when you move over here, you get to look at what I/O resources are being used by every single device that uses an I/O resource in the system, including the hard drive channels, the coprocessor, the numeric coprocessor, the keyboard, and things like that. Again, in most cases, you're never going to have to touch this stuff. So it's just important to know that it's here if you need to. Now, if you've been using computers for a long time, you're going to remember that the nightmare that used to be interrupt requests, or IRQs. Starting with IRQ 0, which was the system timer, and IRQ 1, which was the basic input device of the keyboard. IRQs were every desktop support person's worst nightmare, especially when it came to figuring out IRQ conflicts. As more and more devices had to be added to a system with a limited number of IRQ channels, it got to be very difficult to find ways to share the IRQs, if you could share them at all, or to get the IRQs configured in such a way that everything would work. Not that long ago, hardware devices such as ISA cards that went into, for a network adapter, for example, actually had a series of dip switches that you would have to manually change to change the IRQ on a device so that it would work in different systems. These days, everything just works, really, for the most part. In fact, if you scroll down the list, you'll see that there are no end to the number of IRQs that you're going to be able to use. So there's really not that much in the way of having to handle IRQs that you run into anymore. Again, it's only if you start running into a problem with a hardware device do you really need to worry about this. Likewise, here's the memory resources that are being used by various devices. Again, you're not having any problems, so there's no need to really do too much here. Again, this is just a lookup only tool. If you want to get information about particular devices, such as your CD-ROM drive, that's the job of the components area. When you select a CD-ROM drive, you get all the information you would ever want to know about that particular device, including its plug-and-play device ID, the driver it's using, the name of the device, the type of media that's in the device, and whether or not there is media in the device. The display device is shown here, again, along with the plug-and-play device ID, the memory address it's using, the INF file being used by the device, as well as the driver file. Here's the keyboard. Here's its IRQ of 1 that we saw before, the driver that it uses, how many function keys are on this particular keyboard, and the layout, which is what country is used for the keyboard layout. 409 is the United States. Here you're looking at serial port information, COM1, its baud rate, bit type, stop bits. Basically, if you're looking for any information about COM ports, you can look here. The System Information Utility also gives you a way to look at the software environment for the system. Most importantly, you can look at the system drivers here. And you're going to see that the system drivers are found at Windows System 32 drivers for the most part. System information also gives you a lot of other information that you don't find in Device Manager, including environment variables, any print jobs that might be waiting, network connections, any tasks that are currently running, what modules are loaded in the system. This will take a second. We'll skip it. What services are running, if there are any program groups on the Start menu, and a whole bunch of other pieces of information. Again, this is a lookup-only tool. It's read-only. You're only going to be looking at this information, so don't expect to be making any changes from the System Information tool. But it is a great troubleshooting tool. You've heard me use the word drivers a few times now. You probably already know what a driver is, but let's start with this just so we make sure that we have a good understanding of exactly why drivers are important. Device drivers enable communication between the operating system and hardware devices. The operating system by itself doesn't know anything about hardware. And the hardware itself doesn't know anything about the operating system. The driver is intended to be installed on the operating system and is specifically written for a particular device. So if you look at the little diagram on the screen, you can see that there's a printer. What happens is I install a driver on my computer, and the operating system then knows about how to get to that printer, and that is able to use that printer and all of its capabilities. Drivers are just pieces of software, and they're not all created equally. If you have any problems at all in your desktop environment, they will probably be related to drivers. Drivers can create system instability, particularly if they're poorly written, and there are a whole lot of poorly written drivers out there. So make sure that you are very careful about the drivers that you use, because if you use the wrong drivers, well, you're going to end up having some problems that you really don't want to have. I've had all kinds of nightmare issues with drivers in my IT career. It's just par for the course, and it's something you're going to have to deal with. But again, all that they do is they're a piece of software that sits between the operating system and the hardware device so that the operating system can actually talk to that hardware device. There are a number of ways that you can get drivers on your system. By default, Windows 7 ships with thousands and thousands of drivers that are ready to use. Now, I know I just told you that operating systems don't know how to use hardware. Well, that's the case with Windows 7. Windows 7 just happens to come pre-packaged with a ton of drivers. But each time you add a new hardware device, if the system already has a driver, it will load it. If it doesn't, it'll go out and it'll look at Windows Update to determine whether or not there's a suitable driver for that hardware device. If you don't want your users doing that, that can create a security issue. For example, suppose they install a device that is dangerous to the environment. So, for example, maybe a USB drive or something along those lines. Those devices will simply just work. Out of the box, you can plug a device in, Windows will go out to Windows Update and try to find new drivers to make that hardware work. You can disable that behavior to improve security and to control what devices are actually installed on your system. And we're going to do that in just a second, but I want to finish the rest of this slide first. Many devices also come with a hardware installation disk or CD. You're not going to find a floppy disk anymore, so it's hardware installation disk with a C. And in many cases, the hardware instructions tell you to install the software first. That's because what's happening is the CD software that ships with the device is going to install all of the drivers to the appropriate location on your system. So then by the time you are asked to plug in the hardware device, you're not going to have to worry about the drivers not being there because they'll have already been preloaded. You can also do what's called pre-staging drivers. For example, Global Mantix is going to pre-deploy drivers for specialized network adapters in order to make it easier for the marketing department to install these network adapters when they come in. The result here is a better end user experience and a lower total cost of ownership. Basically, what you're doing here is manually adding drivers to the Windows driver store. There's no magic to it. It's just basically you've got thousands of devices that come with Windows 7. You now have thousands of devices plus one as you add new drivers to the driver store. Now I'm going to go back over to the Windows 7 system. I'm going to show you how you can not disable Windows Update completely, but how you can prevent device drivers from being installed via Windows Update. And I'm going to go to the Start menu, and I'm going to choose gpedit.msc. This is the local group policy editor for the local machine. If you've never used group policy, this is a good time to bone up on it. You're going to be using group policy quite a bit throughout this course, so make sure that you have an understanding of group policy because it's going to be important in your desktop career. Next we go to Administrative Templates, System, Driver Installation. And here you're going to see an option that says Turn off Windows Update Device Driver Search Prompt. So I've double-clicked that item, and right now you see that it's not configured. If you want to enable this, it means that Windows Update will no longer prompt to ask for driver locations when a device is installed. By default, when you pop a device into a system, it's going to ask you if you want to go out to Windows Update to find a driver. And as you can see, this help box here tells you exactly what's going to happen when this item is either enabled or not configured. Now I'm not going to do that. I'm actually not going to turn it off because I want it to stay on. but I want you to understand where to go to get this. Now, by default, everything is not configured in the group policy editor. So you're going to see this note here that says this setting only has effect if turn off Windows Update device driver searching in administrative templates, system, internet communication management, internet communication settings is disabled or not configured. Well, that item is by default is not configured. So if you make this change here, it will take effect. The other thing you should understand is exactly what operating systems this applies to. It doesn't say Windows 7 here, but it is supported on Windows Server 2008, Vista 2003, and XP SP2, and it is supported on Windows 7 and Server 2008 R2 as well, even though it doesn't show it. You can also allow administrators, non-administrators, to install device drivers for particular setup classes. I just want to show you that this is here. We're not going to do anything with it, but you can see that there are some granular controls you can put into place to decide what people can and cannot install. Once drivers are installed, it's important to manage them appropriately. First of all, it's important to understand that driver software can run with full system rights. They can do anything and everything they want to the operating system. So it's important to make sure that your drivers are safe and protected. The best way to make sure that these drivers are safe and protected is to make sure that you run only signed drivers, drivers that have been signed by Microsoft digitally, so that you know that they have not been tampered with. When you have a signed driver, there is a digital signature in the driver that indicates the source of the driver. That is Microsoft generally. And then you can be sure that the driver's actually originated from Microsoft, has undergone security testing to make sure that it's not doing some other things that it's not supposed to, such as installing spyware. Now, that's not to say you'll never use an unsigned driver. Some vendors do release unsigned drivers, particularly beta drivers, so that you can test those drivers without having them have to go through the Microsoft process. However, with unsigned drivers, it is possible that you'll end up with some things you didn't anticipate. For example, suppose you think you're downloading that newest NVIDIA device driver, when in fact you're downloading spyware from some hacker that says NVIDIA. It generally won't happen with signed drivers because they've gone through Microsoft's testing. So be careful about using unsigned drivers on your system. There is a tool included with Windows 7 called SigVerif, Signature Verify, that runs through all of your drivers and verifies that their digital signature is intact and that the files have not been tampered with. I'm going to go over to the Windows 7 sample system we've been using in this lesson, and I'm going to run the Signature Verifier tool against one of the Global Mantix desktops. To start the tool, go to the Start menu, and in the Run box type SigVerif. And you'll see that a program called SigVerif pops up. And you'll see that this is going to help maintain the integrity of your system. Critical files are digitally signed so that changes can be quickly detected. If a file gets changed for any reason, this tool will find out it'll identify the file, and then you can figure out from there what needs to take place. Now, other things can happen to system files as well. If you do happen to get a virus or spyware in your system, the file signature verification tool can help you determine which files have been infected if their digital signature has been altered. So we'll click Start, and it's scanning your device drivers. And if everything looks good, at the end of the process, you'll get this message. Your files have been scanned and verified as digitally signed. So, all of the files that are on my system are in good shape. You'll notice that there is a log file as well. So everything that it did is written to a log file so you can get a look at exactly what took place. And as you can see here, all of these files were scanned and verified as being signed. A number of DLL files in the Windows System 32 folder, as well as a number of files in the driver store, which is located at Windows System 32 drivers. And if you scan down through the list, you'll see that there's quite a few items there that have been scanned and verified as being signed. Once you have drivers installed as well, just like any other software, drivers do get updates from time to time. For example, a vendor may release a new software driver for a piece of hardware to enable new functionality. Now, software updates for your drivers are a good thing in general. However, they don't always work out as expected. For example, just like any other piece of software, a driver update can have a bug, and you may need to go back to an old version of the driver that was stable and worked the way you expected. Remember, driver software runs with full system rights, so bugs in driver software can create system stability issues that require rolling back to old versions of drivers. You can accomplish both of these tasks in a couple of different ways, but primarily through the device manager. I'm going to go back over to the Windows 7 machine for Global Mantix, and I'll show you where to perform both of these tasks. So we'll go to the device manager, again, Start, right-click My Computer and choose Properties, and click Device Manager. Here, you'll notice we have display adapters. If I right-click that adapter, you'll notice I can do an Update Driver Software here, but I can also go to the Properties page's Driver tab, and I can click the Update Driver button. Now let's get some details about this driver. Here's the information we have. So we see what we've got already running. And if I decided to click Update Driver, I get an option that says, what do you want to do? Do you want to search automatically for a new driver, or do you want to browse your computer for driver software? If I click Automatic, I'm going to get a note saying I already have the most up-to-date software, theoretically. So there's no driver update. If I wanted to and I had a new driver that I could not get through Windows Update, this is what happens when you search automatically, then you would just point to where that driver happens to live. And then you would update the driver that way. So you can browse for the new driver, or you can pick from a list of drivers that are already installed on your computer. And if you do that, what happens is Windows goes out and looks for the class of drivers that have to do with the device you're looking for. So, for example, right now I am looking for a device driver for the graphics adapter in my system. So it goes out and looks for any graphics drivers that I already have, and then it says Windows has successfully updated your driver software. Again, it's the same driver I already had, so really no changes were made. So if Update Driver, Browse Computer, if I wanted to, again, I could locate the driver software. This would be useful if you've manually downloaded a driver from, say, NVIDIA or ATI for a graphics adapter. Or you can choose already installed devices and go from there. And from here, if you click Have Disk, it basically does the same thing it would do if you were browsing for the driver on your file system. So the Have Disk button here is sort of redundant. Now here, you notice that this driver is digitally signed. And if you wanted to click the link here that says, tell me why driver signing is important, you can get a lot more information about driver signing and what it does for you. Now, if I had updated this driver, unfortunately, I've searched high and low for a device that does not have an updated driver, and it's tough to find these days. With Windows 7, many of the drivers are brand new, so there's no updates yet for a lot of the drivers for relatively common hardware. If I'd updated this driver and began to have system stability issues, or if I just updated this driver at all, then this rollback driver button would become active. So anytime you update a driver using this method, this button becomes active, and if you need to go back to an old version of the driver, you can click the rollback driver button and it will go back to a previous version of the driver so that you can get back to a stable system situation. While we're here, I want you to see that there are a couple of other options here. One is disable and one is uninstall. The disable button will disable the device, basically turn it off. You want to be careful about this for some pieces of hardware because obviously if you disable your graphics adapter, you're not going to have much in the way of video. So be careful about this because you don't want to disable the wrong device. But it is useful to disable a device that might be giving you problems. In the past, I have disabled things like video capture devices that were giving the system problems, and then I don't have to worry about it anymore until I can find the cause of the problem. You can also uninstall the driver. This is not going to be something you generally need to do a whole lot of, but if you wanted to, you could uninstall the driver for this device and take it right off the system. When you make changes to certain hardware devices, I just updated the video driver, theoretically, even though I didn't, Windows needs to restart. So you'll get a note saying, do you want to restart your computer now? I'm not going to restart because I didn't really make any changes. Windows 7 includes a tool called the Driver Verifier utility that can help you determine the root cause for driver-related issues, including problems related to drivers that experience memory loss or other memory-based type issues, or poorly written drivers. In the general day-to-day operations of a Windows 7 desktop administrator, you're rarely going to have cause to use the Driver Verifier utility. However, it's important to understand that it exists. The Driver Verifier utility is not something that will necessarily help you as a Windows 7 desktop administrator correct a problem. It may help you identify a root cause, but rarely can a Windows 7 desktop administrator rewrite a driver to fix a particular issue, particularly because drivers are closed source, so the source code is not available. Most commonly, if you have driver issues, it's going to be some sort of stability issue like a memory leak. I've seen a lot of drivers over the years that have not well tightened down code, and as a result, they continue to eat away at the amount of RAM that's available in a system. And a Driver Verifier utility can help you point that out and maybe tell the manufacturer, hey, you've got a problem with your driver, here's what I found. Later on in this lesson, at the end of the lesson, you'll find 2 resources that point you to more information about the Driver Verifier utility. I am going to go over to a Windows 7 system now and show you how to enable this utility if you'd like to use it. From the Start menu, go to the Run box and type Verifier, or the search box. This will start the Verifier utility, and you'll notice that the first tasks here are to create standard settings, create custom settings, delete existing settings, display existing settings, or display information about currently verified drivers. Now you'll notice that when you do that, you're not getting any information, because there's no information being captured yet because you've not created any settings. I'm going to choose to stick with the Create Standard Settings task, which is basically going to automatically select unsigned drivers to be analyzed in the driver verification utility. Now, you can also choose to automatically select drivers built for older versions of Windows, or you can automatically select all drivers on the computer. Now, if you don't know where you're having a memory leak, it doesn't matter if a driver is signed or unsigned. A signed driver can be just as poorly written as an unsigned driver, but you just happen to know where it came from. So I'm actually going to change the defaults and choose automatically select all drivers installed on this computer. Now you'll notice that you have to restart the computer for the changes to take effect. Well, I'm going to go back over to that other system where I've already enabled all this stuff, and this is the same process I just ran through, but this system's already rebooted. And here's the results. You'll see that there are a number of settings that are enabled, and all of this stuff is well explained in the driver verification utility documentation to tell you exactly what all this stuff is looking for. Pull tracking is going to look for RAM leaks and things like that. And you're going to see what drivers are being subjected to the driver verification utility. And next, on the global counter screen, you'll start to see exactly what you're seeing come from all of your drivers. And it's only when you start seeing faults and things like that are you that worried. But you should also read the documentation that comes with this utility to better understand what all of these particular counters mean. I want to make sure you understand the utility exists and that it requires a reboot and how to capture the settings, but we're not going to spend a lot of time going through what all of the counters mean. You can also look at just very particular drivers if you want to. So when you go to the next page of the utility, you'll see that when I've chosen the disk.sys driver, I get this set of metrics. And going over to, I don't know, the NTFS file system driver, we get a different set of metrics, which we should. These are what's being captured by the Driver Verifier Manager. When it comes to managing hardware, there are times when you'd want to completely disallow the installation of particular hardware devices. For example, in a lot of sensitive organizations, the use of USB removable storage, such as flash drives or external hard drives, is a big no-no. You don't want data leaving the organization via unauthorized devices, so organizations disable the ability for those types of devices to even be run on a computer. You can also allow and disallow the installation of very specific devices based on that device's specific ID. However, rather than leaving the user in the dark, it's also possible to create custom error messages that are displayed to the user when they attempt to install this kind of hardware. But in the event that a user really needs that hardware, you can provide an administrative backdoor or override that allows IT or other administrative staff to install anything they want on any computer they want, particularly if there is a justification for the organization to do so. After all, every policy is created for a reason, but probably every single policy ever created has an exception. You need to make sure that you're able to take into account those exceptions and work around them when necessary. These hardware installation policies are managed via group or local policy. When you use group policy on a domain controller in the Global Mantix organization, then the policies will take immediate effect or relatively immediate effect on all of the PCs to which that policy is assigned, or all the PCs that are subjected to that policy via the group policy. If you use the local policy editor, it's a very similar process to the group policy, except it affects only a single PC. So if you want to move this policy around, you'd have to do it on every PC in the organization. Group policy is by far the most effective way for this to get done. The local policy editor is identical to the group policy editor you'll find in Windows, except that you can't link it to an organizational unit in Active Directory. You can only subject the local PC to the policy. We're going to be using the local policy editor in these demonstrations so you can see the immediate effect that is had by the implementation of these policies. Because hardware management can be sort of difficult on a virtual machine, I'm going to use the local machine on which I'm recording this lesson to handle all of the group policy or local policy implementation tasks. To get to the local policy editor, from the Start menu, look for gpedit.msc. This is going to start the local group policy editor that you see on your screen. Device installation policies are under Computer Configuration, Administrative Templates, System, Device Installation Restrictions. You'll notice there are some other policies in the parent node, Device Installation, but we're most interested right now in the Device Installation Restrictions. Now I'm going to change this to Standard because it's easier to see. As you can see right now, there are a number of settings that are available in the Device Installation Restrictions folder. One of the ones we just talked about was preventing the installation of removable devices. So if I double-click that policy, you'll notice that this policy is supported on at least Windows Vista. Since we're on at least Windows Vista, running Windows 7, this policy is supported. And this will prevent Windows from installing removable devices. If you enable this policy setting, that's it, you're done. We're not going to do that right now. I want to do something else first, but actually let's do it. I'm going to enable this and click Apply. Before we do anything with it, I want to make sure I display a custom message when installation is prevented by a policy setting. So I'm going to enable this policy, and my detail text is going to be, this is a no-go. And I'll click Apply. And let's display a custom message title as well. This is going to be the message box that comes up. And we'll call it Device Installation Prohibited. Now, let's see what happens when I try to install a device that's prohibited by this policy. The iPhone is a removable device. Therefore, it did not install. Device installation was prevented by policy. iPhone, device installation or installation prevented by policy. That shows that this really works, and it's very effective as a way to make sure that you don't have non-approved devices making their way onto your network. That's pretty cool. Next, let's prevent the installation of a device that matches a particular device ID. I have a Logitech QuickCam, and I have the device ID right here. Now, how did I get that device ID? I actually installed it on another computer, and I looked it up, and I'll show you in just a few minutes where I looked this up. So we're going to enable this policy, and I'm going to add this device ID by going to the bottom here and clicking the Show button. I'll then paste my device ID into this box and click OK. And again, I'll click Apply. And OK once again. Now I'm going to grab my QuickCam. You might hear a little bit of rustling around while I move around. And I'm going to try to install it into my machine. If I can reach the USB port. And again, we find that the device installation was prohibited because I have this machine, this device was sitting in that restricted category that we just enabled. Now let me show you where I got the device ID. Go to the Start menu, right-click Computer, Properties, and go to Device Manager. And let's just open up a device that we've got. I'll go to the keyboard device. I'm going to open its Properties page and go to the Details tab. From there, I'm going to choose a property of Hardware ID, and you're going to see that this happens to have a specific hardware ID, a whole bunch of them actually. HID stands for Human Interface Device, and you're going to see that there's a whole bunch of different hardware IDs. I actually grabbed one of these hardware IDs and was able to block the installation of the QuickCam based on its hardware ID. You have to be a little bit careful, though, about which hardware ID you choose, because if you just choose HID device, any input device will be blocked. So, then if you choose, system keyboard, any keyboard device will be blocked. If you chose the specific, very specific hardware ID you see here, only the specific model of the hardware you're trying to install would then be blocked. So, that's what you're seeing here, and that's how I was able to get my hardware ID to block the installation of the QuickCam. So in some way, shape, or form, you ultimately have to install the device on some system in your organization. And that's what would happen with Global Mantix as well. If they wanted to block something as a part of the Windows 7 rollout, they would have to install the hardware on some machine in the organization just for the simple fact that they have to get the hardware ID. One other thing I want to show you is how to provide an administrative backdoor to allow IT staff to install anything they want. As you can see here, the very first item says allow administrators to override device installation restriction policies. By opening that, you can read the description here that says if you enable this policy, members of the administrators group can use the Add Hardware Wizard or Update Driver Wizard to install and update drivers for a device. If you don't configure the policy or you disable the policy, even members of the administrator group cannot install the hardware. So if you do have to have a back door, then you need to make sure that you enable this policy so that members of the local administrator group can do their jobs more effectively. By simply not configuring this policy, it's not enough, because not configuring this policy has the same effect as disabling, so you can't have an administrative backdoor if you don't configure this device, or this policy. Again, if you enable the policy, all it does is allow local administrators, or in the case of group policy, domain administrators and local administrators, to add devices to the system. There may come a time when you want to add a driver to what's called the driver store on Windows for a user so that when they install a new hardware device later on, they don't need to go out and look for the driver for that device, and you can make sure that they're using a driver that you've tested and approved. You would download the driver package first from whatever hardware manufacturer happens to make the device. In the case of Global Mantix, they have a need to deploy a specialized network adapter for their marketing people to improve storage performance on the network. We're going to go over to a Windows 7 system here in a second and add that network driver package to the driver store so that any person that uses this system later on will not have to go out to the internet to find the driver or go out to Windows Update to find the driver. There's a utility called PNP-Util that stands for Plug and Play Utility, and this is how you really manage the driver store. This is a command line tool, and with the -A parameter, you would add the driver to the driver store. This makes the driver available so that after a hardware device is installed, it would go to the driver store and get the driver. If you combine that with the -I parameter, the driver will also be installed on the system. But if you don't have the hardware, there's really not much point in doing that. So adding the driver to the driver store is sufficient. You can show all third-party drivers that are in the driver store by using the -E parameter, which is enumerate. It will enumerate all of the drivers that are in the driver store from third parties. If you want to eventually delete a driver from the driver store, perhaps you found that it has a memory leak or other flaw, you can use the -D parameter combined with the -F parameter to force deletion if for some reason you have trouble deleting the driver with the -D parameter alone. I'm now going to go over to the Windows 7 system for Global Mantix, and we're going to use the PNPutil.exe tool to add a Broadcom network adapter driver to the driver store for a Windows 7 machine. Here we are at a Windows 7 machine. As I mentioned, this was a command line tool. So you have to start a command prompt, but you should do so with administrative rights. So I'm going to right-click the command prompt and choose Run as Administrator. And you can see here that I'm running it as administrator. Now I've already saved the drivers, downloaded them here. And you can see that there are 3 files, a cat file, an INF file, and a sys file. The INF file is the one that we're most interested in. This has the instructions for how Windows should handle this particular driver. I'm going to use the Plug and Play utility, PNP-Util, and I'm going to add this driver to the driver store by doing PNP-Util-A B57ND60A.INF, and I'll hit enter. And you can see that it's processing the INF file, and it says the driver package was added successfully with a published name of OEM1.INF. Total attempted 1, numbers successfully imported 1. Now, if I go here and I do PNP-Util-E to list the drivers, as you can see here, I now have the Broadcom driver as OEM1.INF in the network adapters class because, again, I got that from the INF file with a signer name of Microsoft Windows Hardware Compatibility Publisher. So you can see that this has actually been added to the driver store. This is good. We wanted it to get added to the driver store. If I wanted to delete this driver, I'd have to use the new name because that other name doesn't exist in the driver store. The B57ND60A.INF was used only for import. It was imported as OEM1.INF. When I want to delete the driver, I use PNP-Util-D OEM1.INF, and I was then able to remove the driver from the driver store. If you want to get more information about the PNP-Util, just type PNP-Util at the command line, and you'll get a full list of exactly what's possible with the Plug and Play utility. These days, USB devices are becoming far and far more common than they used to be. Pretty much everything can be connected to a PC today with a USB connection because it's so easy to use and because USB ports can provide actual power to a device as well. There are 2 different types of what are called USB hubs. There are self-powered hubs and there are bus-powered hubs. Bus-powered USB hubs get their power directly from the system itself, so they're relatively limited into how many devices can be connected to the hubs before the power is overloaded. Self-powered hubs, on the other hand, have their own power supply and can often provide more power to USB devices than bus-powered hubs alone. USB actually has bandwidth limitations, just like a network. USB 2.0 has a 480 megabit bandwidth limitation. If you exceed that USB controller bandwidth, you'll get a message that says USB controller bandwidth exceeded. There are 4 different kinds of varieties of USB, although USB 1.0 and 1.1 are pretty much all 1.1 these days, and those kinds of devices are limited to a paltry 12 megabit connection. If you have USB 1.0 ports on your computer and you try to plug in a brand new 300 megabit wireless network adapter, you're going to be in for a rude awakening when you have only 12 megabits of that bandwidth available because of USB limitations. USB 2.0 has up to 480 megabits of total bandwidth, and USB 3.0, which is just coming out, has a 5 gigabit network bandwidth limitation. Now, gauging bandwidth is truly a best effort task, and it's never going to be exact when it comes to USB, because not all devices, even if they use bandwidth, report their bandwidth back to Windows. So you really have to do some best guess stuff when it comes to making sure that a device isn't overloading the USB hub from a bandwidth perspective. Now, you may wonder just how you can tell if a device is using a lot of bandwidth. Well, there's a tool for that, and it's called Device Manager. I'm going to go over to that right now and show you how you can see both power and bandwidth consumption for particular USB devices. I have plugged in a USB wireless end network adapter to my machine so that you can see how this exactly works. I already know it's connected here to this particular controller, so I'm going to open up the properties for this controller and click the Advanced tab. As you can see, there is a RangeMax wireless end USB adapter that's using 5% of the available USB bandwidth right now. So if you saw this starting to use 80 to 90 to 100% of the USB bandwidth, or there were lots of devices that were all together overloading the USB from a bandwidth perspective, then you could take action to move devices to another USB port. And again, you can refresh if things change. Now, all devices are also connected to a USB root hub. If you find the right USB root hub, and if you want to know how, it's a matter of trial and error. You just go through each one until you hit the right one. And go to the Power tab. As you can see, the total power available is 500 milliamps per port. Well, there are 6 ports available, 6 to 8 ports available on this particular USB hub, which is self-powered. And this device here, the RangeMax wireless end USB adapter, requires 500 milliamps, or the max per port. Now, you don't add these up to get to 500. Each port has 500 milliamps of power. The USB mass storage device that's also connected to this system requires 100 milliamps of power. As you can see, at some point you could overload a USB port hub from a power perspective, so be careful about adding too many high-powered accessories to a USB port. We covered quite a lot in this video. We started by talking about the Device Manager tool, and we actually used Device Manager throughout the entire lesson for a whole variety of tasks. You learn how to view the read-only tool, System Information tool, to view device information in a much more detail than you can get from Device Manager. You learned about the purpose of drivers and learned about the differences between signed and unsigned drivers, and then you learned about some driver installation methods. You then got a glimpse at how you can manage and install drivers, and if you have problems with those drivers, how you could, if you really wanted to get truly in-depth and technical, use the driver verifier utility to make sure that your driver was not doing something crazy that it shouldn't be doing. From a group policy perspective, you learned how to manage hardware installation policies, and then how to stage drivers with the plug-and-play utility to make it easier for GlobalMantic users to be able to add hardware down the line. We then added device drivers to the driver store and wrapped up the lesson by monitoring USB devices, specifically looking at a wireless and network adapter and its impact on USB network bandwidth and power consumption. Thank you for listening to this lesson, and I look forward to seeing you in the next one.